Welcome to our communication system course. In the last class, we have seen why there is a need of modulation and demodulation. Today, we will continue from that point. And first, we will talk about type of modulation. How many types of modulation? That is single tone modulation and multi-tone modulation. We will talk these two type of modulation. First, we write type of modulation. Modulation can be classified into two types. First one is single tone modulation, and another one is multi-tone. Here the term tone means frequency. Tone refers to frequency. It means single tone modulation means single frequency modulation, and multi-tone means multi frequency. Okay, just I am writing the definition of a single tone modulation. Single tone modulation. What is single tone modulation? Single tone modulation. If our message signal contains a single frequency, then corresponding modulation is called single tone. Single tone modulation. Okay, I hope now it is clear what is tone modulation. Next is multi-tone, and multi-tone modulation. The definition is same, except the term single frequency. It is multiple frequency. If our message signal contains multiple frequency component. You can write here component. Then corresponding modulation is called multi-tone modulation. Sorry, multi-tone modulation. Okay, actually this is not a practical approach. This is actually practical approach, because there is no message signal which contains a single tone. It means single frequency. Each and every message signal, we can say that we draw in frequency domain after Fourier transform. We get a band of signal, that is message signal is a is contains multiple frequency. But why we need single tone modulation? For simplicity, to understand the basic concept of modulation. After that, we can handle multi frequencies. Okay, I hope what I am trying to explain is clear now. That multiple tone is basically multiple tone frequency, multiple tone modulation is the practical modulation technique. This is the practical modulation. Okay, but for simplicity to understand, we need single tone, या फिर you can say that a single frequency message signal, single tone modulation, for only simplicity and for to understand the modulation technique. Simplicity. Okay, uh, the mathematical analysis, for mathematical analysis, single tone modulation is easy to understand. That's why if we need a mathematical modulation expression, we use single tone modulation. Okay, we will later the modulation techniques, whatever the modulation techniques we have, we will see that the message signal we will take is single tone modulation, and we will apply that single tone modulation technique into multi-tone modulation technique. Okay. Now, suppose we have a message signal like that, then this is T empty, and the Fourier transform of this is someone like that. We cannot transmit it directly because of antenna constraints. That's why we there is a need of modulation, and modulation we use, suppose we are using a sinusoidal signal. This is sinusoidal signal. Okay, and what we are doing, and the Fourier transform of this sinusoidal signal is like that one, something fc minus fc. If we superimpose this message signal into uh, this message signal into this one, that now our message our modulated signal is like that. It means we are transmitting this message signal at fc, this fc minus fc. This is actually called amplitude modulation. We will see later what the definition of amplitude modulation. Here we have to understand that what we are doing, just superimposing our message into one of the characteristic of carrier. Here we are using amplitude. Okay, the amplitude is superimposing, just the take the peak point of this carrier signal, sorry, modulated signal, and we will get the message signal. Okay, now come to the point that what is modulation, and types of modulation. Okay, first we will write the definition of modulation. What is the modulation, and what are the types of modulation? Modulation is the process, it is the process, it is the process in which one of the characteristic, one of the characteristic parameters, which are the characteristic, which are the parameters, that is either amplitude or frequency or phase. We are talking about amplitude, frequency or phase. These three characteristic of the carrier signal, of the carrier signal will be varied linearly with respect to what? Message signal. Is called modulation. What we are doing, basically we are varying the amplitude or frequency or phase of the carrier signal according to our message signal. If we vary the amplitude, then it is called amplitude modulation. If we vary the frequency, then it is called frequency modulation, and phase, then phase modulation. Okay, just start with amplitude modulation. We will starting with amplitude modulation. Amplitude modulation, here the definition is same. In the definition we can write, it is the process in which amplitude of the carrier. We can write amplitude of the carrier signal will be varied linearly with respect to massive signal. I hope it is clear that here in the definition of amplitude modulation, modulation, we have just taken single point amplitude. Then it is the definition of amplitude modulation. It is the process in which amplitude of the carrier signal will be varied linearly with respect to massive signal. Okay, we have to understand this by taking by some examples. Actually, we have already told you that there is two type of modulation, single tone and multitone. Here we will start with single tone. Then first we are writing the generalized equation. Then we will start with generalized equation for amplitude modulation. Then first we will take with single tone and then we will come later at multitone modulation. Single modulation. Suppose our carrier signal is Ct is equal to AC cos omega Ct, or you can write 2 pi f Ct. Just I am writing here not in terms of angular frequency, we are writing in terms of frequency 2 pi f Ct. Okay, Ct is equal to AC cos 2 pi f Ct, and here our massive signal is Mt. Then our amplitude generalized equation of amplitude modulation we can write with SAMT. This is the equation for amplitude modulated signal, that is equal to AC. That what we are doing, just AC into 1 plus Ka. I am talking about later what is Ka. KAMT cos 2 pi f Ct. What we have done, just we have changed the amplitude. We are replacing AC by AC into 1 plus KAMT. Here what is Ka? K is basically amplitude sensitivity. You can say amplitude sensitivity. Sensitivity of AM modulation. AM modulated signal. Okay. Here we can see that AC into cos 2 pi FCT plus AC Ka into MT cos 2 pi FCT. This is our carrier signal basically, or this is our modulated signal. This is our modulated signal. It means AM signal contains carrier signal as well as modulated signal. We are transmitting there is no need to transmitting carrier signal, but we are transmitting here carrier signal in AM modulation, and this is the main disadvantage. Another disadvantage is the bandwidth we use for the AM modulation. Okay, and if you see that suppose we have massive signal like that, this is our massive signal suppose, and it lies between suppose f minus f. Okay, and sorry, this is we are writing in terms of f, and our carrier signal is like that fc minus fc. This is our carrier signal f, and this is our carrier signal cf. Then our modulated signal will be like that, that at fc, this is basically fc, or this is minus fc, and we will superimpose this massive signal here. Okay, for calculating the power we have to add positive and negative both power. Okay, just both for both signals, for positive frequency as well as for negative frequency. We have to add both power to calculate the total power we are transmitting in AM modulation. And for calculation of bandwidth, we have just we have to see only positive frequency, and positive frequency, this is FC plus FM. Suppose this is FM, this is minus FM, this is FC plus FM, and this is FC minus FM. And if we calculate the total bandwidth, then FC plus FM minus FC minus FM, which gives 2 FM, that it is transmitting 2 FM bandwidth. In the case of AM, we are transmitting 2 FM bandwidth. It is 2 times of message signal bandwidth. Okay. There is I have already talked about the disadvantage. What is the advantage? Advantage is demodulation. Basically, demodulation is very simple. It is we later we will see the demodulation circuit, and we can observe that demodulation of AM is very easy in comparison of other modulation techniques. Today we will stopping here. Okay. I hope from today's lecture you have gained something. If you are gaining something, then please like the channel and subscribe the channel. Like this video and subscribe this channel. Thank you for watching.